For our poisoning attack, I have configured the victim's machine just to know it, and then I scan the network from the attacker side to see if I see the victim's IP on the list. I do. Then I go back to the victim's machine and I ping google.com and I prove there is connection. After running the ARP spoof passing the victim's IP as the target, I'm not able to ping google.com on the victim's machine anymore. I'm not getting any package because the router is with the wrong MAC address, so I broke the communication. Now canceling it and re-ARPing the targets. That's because I'm going to play the man in the middle now with the ethercap. I'll start to sniff the network and just update the host list. And with the host list, I'll play man in the middle, passing the router IP as a target 1 and the victim's IP as a target 2. What happened is both are pointing out to the attacker's machine, so I can basically have the communication going through the attacker's machine, and I'm able to read all the information of this traffic. So I opened any login page, and after clicking login, I'm able to see all the credentials that's being passed through the HTTP request. ICMP redirect attack. I have 3 machines, a victim, an observer, and an attacker, and I know the 3 IPs. So I use the victim's machine to ping the observer's machine, and on the attacker side I run Wireshark, and I'm able to see the packets with the ICMP message being exchanged, right? So what I'm going to do, I run the networks command, networks 86, and what I'm going to do again is to try to ping from the victim's machine to the observer, and I get a lot of ICMP redirect messages, and in all these messages now it's saying that the gateway is the attacker's machine, so it's being redirect. SYN flooding attack. For this I'll run a Python server to be able to access an HTML file from the attacker side. I'm running the server on the victim side, so if I try to open the page on the attacker side, it's accessible, and the SYN cookies are disabled. So what I'm going to do now, I'm going to run an hping3 command to and open Wireshark on the victim side to see all the SYN requests that are sent. There are many and many, and of course they don't complete the handshake, so it gets the server so busy that it's unable to respond the request that previously was fine. So you see the browser's trying to load the page, but it's impossible. Now stopping the SYN flood messages, I'm able, and if I refresh again, I'm able to get the page. Repeating the attack with the SYNCOOKIES on, it makes the server not to persist the SYN message, but it reconstructs it when the ACK message arrives. So although it's being flooded, the server is able to handle all the requests. TCP reset attack. We're going to establish a TELNET connection, and between the observer machine and the victim's machine will be the TELNET server, and on the attacker's machine we're running Wireshark, filtering all the TELNET packets of this communication. As soon as I get them, we can fake a TCP packet with a reset flag and send it to the victim's machine, the server, making the connection close straight away. So on the victim's machine, we're just running Wireshark, filtering the reset flag to be able to see the packet. So as soon as we run the command, the connection is closed on the observer side, and on the victim side, we got the packet with the flag. The same attack had success on SSH connections, because SSH doesn't offer protection against TCP attacks that breaks communication, because it runs on top of TCP. So basically it worked as it worked with TELNET. TCP reset attack on a video stream. I tried two ways. So the first one, I'm running a Vimeo video on the victim side, and on the attacker side, using Wireshark, I'm able to sniff all the packets, and I get one packet and get the port that's being used and the IP that's being used. So port 443 for HTTPS and 80 for HTTP. And what I do, I send a TCP message with the reset flag to Vimeo server, pretending that I'm the client, pretending that I'm the victim, and the connection is cut straight away. The other way was to send the TCP packets with the reset flag to the victim's machine, so pretending that the Vimeo wants to reset the connection. And what happened is the video gets very choppy. It freezes a bit for a few seconds, but it doesn't stop, because even we're sending reset flags to the victim's machine, the Vimeo server keeps sending the video packets as well. ICMP blind connection reset attack. We established a telnet connection between two machines, the observer and the victim being the telnet server again. On the attacker side, we're running Wireshark to sniff all the packets, filtering the telnet packets in particular. Then we're running the networks82 command, and it doesn't seem to have any effect. It doesn't break the telnet connection, neither any connection to any website using the browser. Although we can see the packets arriving on Wireshark, we can see them, but they don't seem to have any effect. And code 2, code 3, and code 4 were used trying to break the connection using this kind of attack, but it just doesn't seem to have any effect. The code doesn't make any difference, and the attack failed. ICMP source quench attack. On the victim side, I'm opening two pages just to prove there is connection, one HTTP and the other one using HTTPS protocol. I'm also running Wireshark, filtering the ICMP packets, and on the attacker side, I'm running networks 85 attacking ports 80 and 443. So when I refresh the page, I can't see any real difference. Although I can see on Wireshark all the packets are arriving with the message, with the source quench message, having no effect or very small effect on the network speed. Then I decided to use the observer machine to attack as well. So they're attacking the same ports, 80 and 443. And this time the video on Vimeo got way slower. TCP hijacking attack. For this attack, I'm using three machines, a victim, an observer, and an attacker. And I establish a telnet connection between the observer and the victim, being the victim the telnet server. On the attacker side, I have Wireshark running in order to inspect all the packets exchanged between the other two machines. And I'll use a tool called HIJACK to hijack the connection. So what I need to do, I need to pass the machine's IP and the port being used for the communication. After running that, the tool just wait for another packet being exchanged, get the ACK number and the sequence number, and it is able to hijack the connection. And I can do basically anything I want. I'm creating a folder and removing that right after on the victim's machine. And I can see on Wireshark the packets that were sent by the tool HIJACK with the sequence number generated